right, it's going on page 144 when we are done. And we know how to do rectangular coordinates and all kinds of things with them. We've plotted some polar ones, but we're going to look at converting back and forth. So the good news here is that if you look on your vector notes on page 140, which I'm hoping I actually opened, I intended to. Okay. So here are some vector notes from page 140. A lot of what we do today is going to look very, very similar to this. Okay, a vector is a directed line segment, right? And if it's in standard position, then the tail is at the origin, right? It doesn't always have to be, but if it's in standard position, it is. So really one of the differences, because it's not like this is a polar point or anything, but for the vector, we have the whole directed line segment that we draw. For the polar points that we're plotting, we're just plotting the point, which would be right here, okay? But really finding this stuff and the relationships are all going to look very, very, very much like this. It's almost going to feel like it's the exact same thing because the relationship between x and y and r and theta is all the same. So when we look at what we have here, here's a little triangle, right? So we know that if this is my point, these are perpendicular, this is my x value, this is my y value, this would be r, right? So this is theta, and I would rotate that way. So we know, and have known for a very long time, whether we knew how to do polar or not, we know that in this case, x squared plus y squared would have to equal r squared. That's just straight up Pythagorean theorem. Still applies to even more complicated stuff. I can do a few different trig relationships with theta. So I can say that the tangent of theta is what over what in this picture? Y over x. Good. And then cosine theta would be what? X over r. And sine theta would be equal to y over r. So this, we actually first looked at it that way when we started doing the unit circle, right? Because if the radius isn't 1, then this is the relationship that you get for cosine, sine, and tangent. And then we use it again in vectors and using it again now because the relationship's still the same regardless of how we're going to apply it. So if we are given a polar point, which when we looked at yesterday, we know it's in the form of r comma theta, but we want to change it to a rectangular point in the xy form, then we know from over here that if I have r and theta, right, I can figure out x. So if I know these two things, I can figure out x. So if I just take that and solve it for x, I get that x equals what? If I'm going to take the cosine theta equals x over r to solve for x, I would multiply both sides by r, right? So this gives me r cosine theta. And what does y equal? R sine theta. Does that look familiar? Yeah? Should look familiar from physics and from vectors, right? I think you call it mg instead of r. But as an ordered pair, it's r cosine theta, r sine theta. Now for the vectors, these had pointy brackets because it was the that form for our vector. But this is an ordered pair that we get to actually go and plot because we're not actually drawing a vector here, it's just one point. Okay, but it's a directed point instead of a directed line segment. Everybody okay with that? So if we have r and theta, we can get it into x and y. This is our xy form right here. This is x, this is y, just substituting that stuff in. Everybody good with that? Easy enough? All right, so then let's say that we have rectangular, but we want to convert it to polar. Since we know that x squared plus y squared equals r squared, then we know that r has to equal what? Square root of x squared plus y squared. Does that give me r equals x plus y? No, absolutely not. Okay, and then if tangent of theta equals y over x, then theta equals the tangent inverse of y over x. This is what we use when x is positive, but we use theta equals tangent inverse of y over x plus what if x is negative? 180. So 180 degrees or pi if we're in radians, and that's when x is negative. Because remember, when you take the inverse, you're only getting angles in the first and fourth quadrants, but the angles can actually be in all of the quadrants. Does that look familiar? It's vector stuff all over again, right? But it's not vectors that we're graphing, it's just a point that we would be plotting here. We all good? All right, so now let's look at these graphs real quick before we go convert some things. This says graph the following polar equations. Now yesterday we just plotted points, okay? We did not graph equations. So we're going to think about what would make sense here if we were going to actually plot or graph these equations here. Instead of having a point where I give you a radius and a theta, my equation is r equals 4. Okay? So that tells you that, what does r represent really? The radius, right? So the radius is 4 for all thetas, right? For all angles, r equals 4. So what do you think that's going to look like on here? When theta is 0, what is r? 4. Okay, so let's plot that. 1, 2, 3, 4. Okay, that has a radius of 5. Just so you know. When theta is pi thirds, what's r? 4. When theta is 5 pi sixths, ooh, that's a 3. Dang it. Help if I could plot it on the right point there. There we go. When theta is 5 pi sixths, what's r? 4. When it's 4 pi thirds, what is it? 4, right? And so for every single angle, it's 4. What's that going to look like once I plot the infinite number of points I can plot? A circle. So if you have a polar equation, it's kind of like when you're graphing lines and you have like y equals 3 and x equals 3. Those are super easy to graph, right? You don't have to overthink them. As long as you don't get them backwards, you're good. This is telling you the radius is always 4. Well, the circle is what has the radius. There you go. Okay? So now we look at this one. Theta is equal to 2 pi thirds. So this is an equation. It's not a point that we're going to plot. So I can go and find my theta. Here's 2 pi thirds. That means theta is 2 pi thirds always for every radius. So when the radius is 5, it's 2 pi thirds. When the radius is 3, it's 2 pi thirds. When the radius is -1, it's 2 pi thirds. So once I plot all infinity of those points, what's that going to look like? A line, yes. Okay. And you don't necessarily have to make it dotted, but if I don't, I'll never get it straight. So it's a different way to represent them. And I did say then convert to rectangular form, but we're going to do that right now because I feel like we wouldn't have a lot of time. Actually, on this one we can. We'll do this quickly, but I don't want to have to go through that one there. This is a circle. Where's the center? What's the center point for that circle? 0, 0. What's the radius? 4, right? So to write the equation of the circle, that's just x squared plus y squared equals 16. There you go. Easy enough? Okay, I don't want to throw you off by doing this one just yet, so we're going to go look at how to convert some other things before we do that one. All right, so this is the rectangular form. That's your polar form. Gives you the same circle. All right, so we're going to come back up and use these graphs in just a minute, but we're going to go ahead and convert these. It says write the polar coordinates as rectangular coordinates, then graph. So we have this first one where we have 3 and then pi halves. So we know that x is r cosine theta. So x equals 3 times the cosine of pi halves. So it's going to give me 3 times, what's the cosine of pi halves? 0. Okay, pi halves is 9, is 0. So it's 3 times 0, so x equals 0. Then y equals 3 sine of pi halves. So that's 3 times, what's the sign of pi halves? 1. So y equals 3. So my point in rectangular form for point A is 0, 3. Easy enough? All the ones on your notes are going to be the ones that you know from the unit circle in exact form. There will be a couple on your homework that are not the special angles where you're going to have to use a calculator, but I figure you know how to use the calculator, so I wasn't going to bother wasting the time getting them out. I mean, if this was, you know, pi sevenths or something, then I would just have to type that in the calculator and round, and that's okay. But if it's exact, I want it exact. All right, so here, x equals -4. So this is our cosine theta, so -4 times the cosine of 3 pi fourths. All right, so my reference angle for 3 pi fourths is pi fourths. What is the cosine of pi fourths? Square root of 2 over 2. 3 pi fourths is in which quadrant? Second. So is it going to be positive or negative? Negative. So this is -4 times negative square root of 2 over 2. So x is equal to positive 2 square root of 2. Then y equals -4 sine of 3 pi fourths. My reference angle is still pi fourths. Sine of pi fourths is what? Square root of 2 over 2. And that's in the second quadrant, so is it positive or negative? Positive. So it's square root of 2 over 2. So that means y is going to be a negative 2 square root of 2. So my point for B is 2 square root of 2, negative 2 square root of 2. We good? All right. C, x equals 4 cosine of 0. And these could be in degrees or radians. When it's 0, it doesn't really matter. But yeah, degrees or radians they could give you. This gives me 4 times, what's the cosine of 0? 1. So x is 4. Then y is 4 sine of 0. So that's 4 times 0. So y equals 0. So point C is at 4, 0. Well, that looks very much like the polar form, doesn't it? Now we're going to graph these. Okay, so I'm going to go back up here. I'm going to have to pull my paper because I can't see my. And we're going to plot A on both of these. Okay, so my rectangular A is at 0, 1, 2, 3. There's A. My rectangular B is at 2 square root of 2, negative 2 square root of 2. Okay, so here's some things that are going to help you out in life just to kind of remember and know to estimate in your head. Like, I'm not going to go get a calculator and get it for sure, but I can estimate close enough. Square root of 2 is about 1.4. There's no need to estimate in your head to 3 decimal places because that just gets weird. But square root of 3 is about 1.7. So we can kind of estimate where to plot these things. So just things that you want to be able to know to help you out. All right, so we're trying to plot 2 square root of 2, negative 2 square root of 2. So if the square root of 2 is about 1.4, then 2 of them is about 2.8. So I would go to the right, about 2.8, and then down about 2.8. So it'd be like right there. There's point B. Then C is at 1, 2, 3, 4, 0. Now we're going to plot the polar points that we had. That 3 pi halves, which part do I want to find first? The 3 or the pi halves? The pi halves. So I'm going to go to pi halves, and then I'm going to make my radius 1, 2, 3. There you go. There's A. B is 3 pi fourths. So I go to 3 pi fourths. The radius is negative, so what do? Go through the pole, right? So 1, 2, 3, 4. There is my B. And then C is the angle 0, and then 1, 2, 3, 4. Now look at those two graphs. What do you notice about the points? They're in the same places, right? I tried to make them as close to the same scale as I could, but it's at least close enough for you to figure that out, right? So does that make sense? It's the same points. The points are in the same place. These two coordinate systems are just different ways to define where that place is. Okay? So that can kind of help you wrap your mind around when you get weird stuff like, those are the same. That seems weird. Well, they are the same because it's on an axis. Okay? Everybody good? Any questions? All right, so now we're going to write the rectangular coordinates as polar coordinates, and then we'll go back up and graph those as well. So to do these, then I'm going to start, I need the radius and I need theta. So I know that r is equal to the square root of x squared plus y squared. So r is equal to the square root of negative 3 squared plus 3 squared. So that's 9 plus 9, that's the square root of 18. So when I simplify that, what does that give me? 3 squared root of 2, good. 3 squared root of 2. Good? Then I need theta. Well, theta is the tangent inverse of y over x, 3 over negative 3. But x is negative, so what do I need to do? Add 180 or add pi. And since I put these graphs on here in radians, we'll add pi. This is the same thing, though. Okay. So this is really the tangent inverse of negative 1, right? So the tangent inverse of negative 1 is what? This gives me negative pi fourths, right? Is that what the tangent inverse of negative 1 is? Right? Because it's negative. And then I'm going to add pi to it. So what does that give me? Three pi fourths. Think about it this way. These points are in the same place on the coordinate, right? And so our minds, you're going to think easier in rectangular coordinates because you've been looking at those forever. Negative 3, 3 is in the second quadrant, right? So this angle, guess where it has to be? In the second quadrant. Does that make sense to you? So you can wrap your mind. That's why it's important to know that they really are the same thing, so you can make sure that you have the right angle in there. Does that make sense to you? If you get all that confused, you just make sure your angle's in the right spot. That's why I'm giving you that scratch paper. If it helps you to go plot them to make sure even some of the equations that we're going to do, like, okay, yes, these are the same thing, so now it makes sense to me. So for D, my point is at 3 square root of 2, 3 pi fourths. So we're going to go ahead and plot this one before we do the other ones so you can kind of see what I'm talking about with that. The negative 3, 3 totally should make sense to you, and you know where it is, right? So negative 3, 3, and that's point D. Right? So I know that should kind of be about where, I can't just go over there and like put a point on there. I still have to do a little thing here, but I can get to about the right spot. So I've got, what is it? 3 pi fourths, so I go to 3 pi fourths, and then my radius is 3 square root of 2. Well, the square root of 2 is 1.4. So twice of that is 2.8, so 3 would be like 4.2, right? Close to that. So I'll go here, and I'm going to go to 1, 2, 3, 4, 4.2-ish. See, depending on your numbers, sometimes it's easier to count left and right. Sometimes it's easier to count diagonal. It just depends, but it's kind of in the same spot. Okay. All right. For E, R is equal to the square root of 1/3 squared plus the square root of 3 over 3 squared. What's 1/3 squared? 1/9. What is the square root of 3 over 3 squared? What do you get in the numerator? What's the square root of 3 squared? 3. Okay, but hang on, because y'all are jumping ahead of me, because yes, it is 1/3. But it's 3/9. Now, it does reduce, and we're used to reducing, and you want to, but do I really want to reduce right here? No, because I already have my common denominator. Does that make sense? So 1/3 isn't wrong, but then I'd have to combine, so that's why sometimes you just don't want to get ahead of yourself. Okay, that's why it makes sense now while y'all were kind of staring at me weird. Square root of 4/9, right? Can I take the square root of 4/9? What does that give me? 2/3. So R is equal to 2/3. There's my radius. All right, so then I've got to find theta. So theta is equal to the tangent inverse of, so it's going to be the square root of 3 over 3 over 1/3. Isn't that the same thing as the square root of 3 over 3 times 3 over 1? That's y over x. I'm just going to kind of simplify it there. So those cancel out. So I want the tangent inverse of the square root of 3. So we know that it's either 30 or 60. Which one is it? Or pi 6 or pi thirds? Pi thirds. Good, it's the higher one. So that means that theta is pi thirds. So my point then is at 2/3. Oh, goodness, I cannot even write pi thirds. So let's go graph that one. That one doesn't look like it's going to be very fun to graph because it's teeny tiny up here. All right, so I've got to do 1/3, and then square root of 3 over 3. All right, so square root of 3 is about 1.7. Now we're estimating and not really well anyway, so wouldn't it be easier to divide 1.8 by 3? Right, so what's 1.8, because that's like 18. What's 18 divided by 3? 6. So 1.8 divided by 3 would be like 0.6. So it's somewhere right around there. So I'm going to go about 1/3 and then about 0.6. Close enough for our little estimation here. That's E. So when I go over here, I go to pi thirds, but my radius is only 2/3 of a unit to about right there. And that still looks like it's about in the right spot. Okay, we good? Awesome. All right, last one of these, then we're going to look at equations. R is equal to the square root of 0 squared plus negative 3 squared. It's the square root of 9. So R is 3. And then theta is equal to the tangent inverse of negative 3 over 0. Now that's undefined, right? So when it's undefined, tangent's undefined at pi halves and 3 pi halves. And this is where you want to, if you have an idea of where that point is, it's on an axis, right? And if they're on an axis, you kind of already know what the angles are, but I think it's good to think about the process too. So if my point is 0, negative 3, tangent, the theta I'm actually going to use, is it going to be pi halves or 3 pi halves? 3 pi halves. Good. So theta is 3 halves. So my point F then is at 3 pi halves. Okay. Everybody good with that? So now we're going to go back up here and we'll graph these. We're going to graph 0, negative 3. And that is at, that's F. And then my 3 pi halves and 3. And that is F. Everybody good? Some of these require less work. I mean, we did work on all of them, but sometimes you just kind of know where things are, and that's okay. All right. Any questions at all? Ask me now before we move on to equations. Okay. All right, so I need, oh, shoot. All right, so just as a quick little reminder from the front and a reminder from vectors and everything else, we know that R is equal to the square root of x squared plus y squared. We know that theta is equal to the tangent inverse of y over x. We know that x equals r cosine theta, and we know that y equals r sine theta. Remember this, no matter how complicated and weird things get, and we're in polar, like trig doesn't freak you out anymore, square roots don't really, things like that don't freak you out like they did when you very first started doing them. But the algebra steps are the same. The basic algebra behind all of it is the same. Even when you get into calculus, it's the basic algebra. Well, it's the basic algebra now, too. That's what's kicking your butt. It's not the concepts that we're working on. But the processes are all the same. I have these equations right now in rectangular form. I want them in polar form. So we're doing basically the same thing we did to change the points, the ordered pairs. But in this case, it's an entire equation. All it is substitution. It's basic substitution that you've been doing forever. So if I have y equals x, that's rectangular talk, right? I know what x is and I know what y is, so I can just take these things and substitute them in. Instead of y, we're going to have r sine theta. And instead of x, we're going to have r cosine theta. Does that make sense? Just straight up substitution. But then we have to solve. Most of the time you're solving for r. Sometimes you solve for theta, and I'll show you how you know. Solve for r if you can. So we're going to try and get r by itself. I'm going to start, though, by, well, if I divide both sides by r, what happens? They cancel out. They go away, right? So this really just leaves me sine theta equals cosine theta. All right. Well, at this point, then, I can either divide both sides by sine theta or divide both sides by cosine. I could subtract also, but if you think about your identities, sine and cosine, just one of them being added and subtracted, it doesn't get me anywhere. But what about sine over cosine or cosine over sine? Did those get me somewhere? They did. They get me a tangent, right? So I'd rather divide both sides by cosine, and I'll get sine theta over cosine theta, which is going to give me 1, right? Doesn't give me 0. That means that tangent theta is equal to 1. So theta is equal to the tangent inverse of 1. What's the tangent inverse of 1? Pi fourths. Now, what else could it give me besides pi fourths? Doesn't it give me a third quadrant angle also, right? But remember from the front, when we graphed something like this on a polar axis, didn't it graph me a line? It means theta is always that, so it's going to go through that other one anyway. Because look at what we did here. Oops. Well, let's just say that we did it here. If I graph pi fourths, that means theta is always pi fourths. So when I actually draw that in, it takes care of 5 pi fourths also. Does that make sense? That's why you don't have to have both of them. Even if I said theta was 5 pi fourths, I'd still be right. Even if I did it, the negative angles, it's all the same because you have so many different options there. Okay. All right. Everybody good? All right, so we're going to do substitution here. Instead of x, what do I substitute in to get it into polar? Okay, good. R cosine theta equals 0. Now, I could divide both sides by cosine theta, because I could have started that way over there, too. If I'd have started that way over here, I would have ended up with the same thing, because I would divide, and then I'd divide, and the r's go away, or whatever. But if I divide both sides by cosine theta here, I get r equals 0. Well, that means the radius is 0. Can you have a circle with a radius of 0? No, so that doesn't even make any sense, right? So maybe I can't solve this, or maybe instead I'm going to divide both sides by r. If I divide both sides by r, then that gives me that cosine theta is equal to what? 0. So theta is the cosine inverse of 0. What's the cosine inverse of 0? Come on, people. When is cosine 0? When is your x 0? Pi halves, good. Theta is equal to pi halves. These are lines that you would graph in the coordinate plane. So are these. Okay, if you have the parent function or a horizontal or a line that goes through the axis, then hopefully that should make sense. Because the slope here is 1, right? So when you have a slope that is 1, that's going to go right through a 45-degree angle, right? It makes you a 45, 45, 90 triangle there. Okay, so now let's look at this one, because these might be something that you could just reason through by looking at the graph. C doesn't work that way, okay? So when you get C here, y, instead of y, what are we going to substitute in? R sine theta, and that's equal to negative 5. So I want to solve for r when I can, so I'm going to divide both sides by sine theta. R is equal to negative 5 over the sine of theta. And we're done. Or, what if I didn't want sine in the denominator? How else could I write this? What's the reciprocal of sine? Cosecant. These are the same thing. Either one of them is fine. Everybody okay with that? Any questions? We good? Okay. All right, so I'm going to take you through the long way of D first, just because I want you to see that all this substitution works every time. When in doubt, just substitute your stuff in and work it out, and if you handle your algebra, which shouldn't get too crazy, then you'll be fine. So instead of x, I'm using r cosine theta, right? But it's squared. Plus, instead of y, it's r sine theta, and it's squared. And that's equal to 7. Everybody good? All right, so when I square this, this becomes r squared cosine squared theta plus r squared sine squared theta equals 7. I got to get r by itself, so what would I do here? Factor. I heard the factor word. Oh, I'm so proud. Okay, I'm going to factor out the r squared, right? We got a GCF here. So we get r squared times cosine squared theta plus sine squared theta equals 7. What is cosine squared theta plus sine squared theta? 1. Remember your identities? So r squared is equal to 7. Now let's just pause here for a second. Could I have skipped all this step and just started here? Remember from the very first thing we wrote down today besides the page number? X squared plus y squared equals r squared, right? Because r equals the square root of x squared plus y squared. So you can do a straight substitution like that. That's why I said I'm going to take you through the long way, because I wanted you to see what happened. It still works out, because sometimes you have to substitute these in. Sometimes there isn't a shortcut to it. So I want to make sure that you understand that, yeah, it's going to get me there if I do my algebra correctly, but really x squared plus y squared does equal r squared. This gets me to that. Now, I don't want r squared equals 7. I want r equals the square root of 7. Technically, r equals plus or minus the square root of 7, and you can have a negative r in there, but since, what is this going to graph? A circle. It's going to graph a circle. So it's going to take care of that negative 7 anyway, so you don't have to have that. It's just, if it graphs a circle on the rectangular coordinates, it's going to graph a circle on the polar coordinates. Okay? We good? All right. Well, let's look at this one. So we know x squared plus y squared is r squared, but that's got the 2's in front of it. So what can I do? Factor. Okay, factor out of GCF. So I'm going to get 2 times x squared plus y squared equals 5. So this is really just 2 times what? R squared equals 5. Can I take the square root of both sides right here? No, what do I have to do first? Divide. So r squared equals 5 halves. So r is equal to the square root of 5 halves, which is the same as the square root of 5 over the square root of 2. And what's wrong with this answer? Can't have a square root in the denominator, so I got to rationalize whether you write it out or not. You still have to do it. So r is equal to the square root of 10 over 2. Because when I just give you a radius and you're in the polar coordinate system, it's just graphing a circle. And that's what that would graph right there as well. Okay. Are we good? Any questions? All right. So now we're going to go the opposite direction, and then we're going to convert 2 rectangular equations. So instead of r equals 12, what can we substitute in for r? At the top of your page. Good. Square root of x squared plus y squared. That substitutes in for r, and that's equal to 12. Well, I don't like that, so what can I do? How can I get rid of that square root? I'm going to square both sides. So this gives me x squared plus y squared equals 144. This gives me a circle. The center is at the origin. The radius is 12. Bam. That's what that does right there in the polar system as well. Okay? Just the equation just looks a lot nicer in the polar system. We all good? All right, so I'm in polar. I've got r sine theta equals 4. What do I substitute in for r sine theta? Y. So y equals 4, and I'm done. Okay? The line y equals 4 is way more complicated in the polar system, right? But it still would graph the exact same line. Well, good? All right, so here we've got r equals -2 secant theta. All right, so I'd really like to get rid of the secant and make it into a sine, cosine, or tangent. So r is equal to -2. What's the reciprocal of secant? Cosine. So it's -2 over cosine theta. Now, I don't have anything that I can just straight substitute for cosine theta, and I'd also like it out of the denominator. So to get it out of the denominator, I can multiply both sides by cosine theta. Would you agree with that? So that's going to give me r cosine theta equals what? -2. Now, do I have something to substitute for r cosine theta? X. So my answer is x equals -2. And this is just a vertical line. Okay. We good? Any questions? All right. So now I've got theta equals -45. So what can I substitute in for theta? What do you look at the top of your page? Tangent inverse. Tangent inverse of y over x, because remember, we wanted to get it in the rectangular coordinate system, so x and y make sense in here, and that's equal to -45 degrees. Well, clearly, I don't ever graph anything like that in the rectangular coordinate system. So how do you undo the tangent inverse? What's the inverse of tangent inverse? Tangent. So I'm going to take the tangent of both sides, which means on the left, I get y over x, and on the right, I get the tangent of -45 degrees. Okay, so what's the tangent of -45 degrees? Positive 1 or negative 1? Negative 1, right? All students take calculus, so cosine is the only thing that's positive here. So this is in the fourth quadrant, so that means that the tangent inverse of -45 is going to be -1. Everybody with me? So you get y over x equals -1. What do I do to solve for y? Multiply both sides by x, so y equals -x. Everybody good with that? Yes? Awesome. All right, so last one. So r equals 6 cosine theta. Well, I don't have anything to straight substitute for r. Well, I do. I can do the square root of x squared plus y squared, but I don't have anything to straight substitute for the cosine of theta. So I need to kind of get these together somehow. For that cosine of theta, for me to be able to substitute, it has to have an r with it. So I can get an r with it, but not by dividing. So I'd have to multiply this side by r, which means what would I have to do to the other side? Yeah, I'd have to multiply both sides by r. So if I multiply both sides by r, right, this is going to give me r squared equals 6r cosine theta. Everybody with me so far? Now, what can I substitute in for r squared? X squared plus y squared. Good. So this can become x squared plus y squared equals 6 times what? X. Okay. So what do you think this is going to graph? X squared plus y squared. What kind of thing does that normally graph me? A circle, right? So it's going to graph me a circle, but I've got to fix the form here. So I'm going to move the 6x over. So I'm going to get x squared minus 6x. And then I'm going to leave a space, because remember, with your circle equations, it's x minus h squared plus y minus k squared equals r squared, right? So this is where the whole completing the square comes in. I'm going to leave a space because I'm going to have to complete the square, plus my y squared. And then whatever I add in here, I have to add over here so I can complete this square, right? What would I add to both sides to complete the square? Plus 9. Good. And remember, if you haven't finished this stuff in Khan Academy, I extended it a day because of my mistakes. There are 12 questions. You don't have to watch the videos. You just have to go answer them. They're there if you need to, but you need to know how to complete the square. So once I've completed the square, this now becomes x minus 3 squared plus y squared equals 9. There is the equation of my circle. In this circle, in the rectangular coordinate system, the center would be at what? Where's the center point of that circle? Remember, for circles, it is x minus h squared plus y minus k squared equals r squared. And the center is at hk, and r is clearly the radius. So the center is 3, 0, and your radius is... So, got to be able to complete the square to get your circle. Okay? Any questions at all? Substitute. Think about what you're doing. When you are going from polar to rectangular, you got to try to get rid of the thetas and the r's and change them to x's, and it's the opposite the other way. All it is straight substitution, and these 4 things right here will get you everything you need. Because you know from here it's r squared equals x squared plus y squared and things like that. Those are the 4 things that can get you in both directions. Okay? Any questions? We good?